We have like an amazing group of people. Oh, one last person joining. Okay. Right, now we are officially good to kick off. Once again, thanks again for joining today's session. Before we actually begin today's presentation, we thought it would be good to cover a few things. First of all, if you haven't yet done so, please download the Jeng app, which we are going to be talking about in great detail. So it's available on Google Play and the App Store. Once you've done that, or while you're doing that, allow me to do some quick introductions in terms of some of the people who are going to be taking you through today's presentation. The first bit will be briefly covered by me. My name is Eddie Azadi. I'm part of a team at Google called the Partner Innovation Team, and I'm one of the creative directors. And a lot of my role is trying to see how we can create meaningful experiences for our priority markets here in APAC. And the most recent project we've just launched is this wonderful thing called Jeng. I'll pass over to my other colleague, Elaine. Please introduce yourself.
All right. Hi, everyone. Good evening. Thank you so much for joining us tonight. My name is Elaine. I'm from the same team as Eddie, part of Google Partner Innovation Team. I run the strategy and programs across Greater China for the team. And I'm going to pass this to Shan, who's our tech lead for this project. Shan.
Hello. Hi, I'm Shan. I'm a creative technologist from the same team. And I'm driving the technical design and the architecture evaluation, and generally speaking, anything technical with this project. Thank you for coming.
Yes, thank you so much for coming. So you've got three of the four people who worked on this from the Google Pi team. So we definitely wanted to kind of do the story justice. So let me kick it off. Today's session, as I said, is really talking about our process of creating this unique platform called Jeng, and some of the learnings and some of the potential insights that you can all hopefully gain from it in your kind of future endeavors and projects. I'm sure, as you are all very much aware, there are so many ways that you can use AI and ML in ways that could potentially be useful, meaningful, and even fun. And we're here to share one recent example that we built together with the Google Hong Kong team. Just to give you a bit of context, what exactly is the Partner Innovation Team? Well, our responsibility is really to try and create the kind of projects where we have an opportunity to make any kind of meaningful or tangible impact to the users across this region. So doing this project for Hong Kong is no exception. What I'm going to go through today is, probably how the project came to be, some of the challenges that we potentially face, what were some of the key learnings, and ultimately, we're more than happy to open it up for a few questions, if there are any, for us to kind of have some lively discussion. But again, I think what really makes us proud about this particular project is that this was an idea that was made specifically for Hong Kong. So it's not something that was adapted or replicated from other markets. So all the more reason this particular project was very special for us. So for the next few minutes, we're all gonna cover quickly how this project came to be, how we put it together, and who we partnered with to help make this happen. So I guess it's always good to start at the beginning. So I'm gonna talk to you briefly about how it all started and what the ultimate ambition was, just to give you a bit more context. This project was initiated by the Hong Kong team at the end of last year. And it was really a question of, they had invited us to really try and see what we could do to help Hong Kong recover in some way, right? So with the Google Hong Kong office, instead of having like some sort of velocity plan for the business, they really wanted to focus more on a recovery plan. And they had invited our team to see how we could potentially support it. So from our perspective, recovery means quite a lot of things. For us, it's about trying to see how we can help renew optimism, help people regain positivity, also kind of reconnect people in communities across Hong Kong, right? So we really wanted to see how we could create something that could help people in Hong Kong rally in a positive way. Which is how we came up with this notion of like Project Share Joy. That was always like the code name that we had for it. From our perspective, you know, we had a very simple premise. What if we can actually create something that encouraged people across Hong Kong to share what makes them happy, right? So like I said, we wanted the project to be hyper-local. We wanted it to be made for Hong Kong by Hong Kongers, using all of Hong Kong as the inspiration and the canvas. So what we did was that we basically helped to kind of pre-identify several things together with the Google Hong Kong team that could potentially kind of spark joy for everyone, right? So it could be like a popular dish, a drink, an object, a specific place, or an activity. And we wanted to encourage everyone in Hong Kong to go forth and find it. And ultimately, it would lead to them having the opportunity to kind of play and share it. Right? So this really led to the creation of the Hojang platform. Now, I know that this is like a huge simplification, but I think it's just good to kind of give you a quick overview of what we call, you know, like the special sauce or the magic ingredients to this overall platform. As you're all aware, we used AI and ML to train and detect the objects. So fun fact, TensorFlow just recently celebrated its 5th birthday, and it's by far one of the most popular machine learning libraries in the world, right? I think they've had over like 160 million downloads, and I'm sure there's a lot of people in Hong Kong that are also using it as well. We, of course, use AR Core to help bring the experience to life. So ultimately, we wanted to create something that was accessible both on Android and on iOS as well. And the last bit is really, you know, like just some playful storytelling and creativity, right? So we had the opportunity to work with some world-class production houses to help kind of create and design these wonderfully local characters. And I guess when you all put it together, you know, it kind of results in something really playful like this, right? So again, we had trained the ML to kind of identify specific objects and things in the real world within Hong Kong that could naturally kind of trigger the creation of these kind of fun characters based on those objects or symbols. Our aim was to really try and see how we could kind of encourage people to almost go on like an interesting treasure hunt of sorts, right? Where they could try and figure out the clues and try not to talk over the lion, and ultimately, you know, unlock these amazing characters, hyper-local and so true to what makes Hong Kong, Hong Kong. So in terms of these colorful characters, I just wanted to give a quick overview in case you haven't, you know, downloaded the app or seen it before. We were fortunate enough to kind of arrive at a really fun list of colorful characters, right? We kind of managed to come up with 7 overall. I think we started with a master list of, you know, over 50 or maybe even 100 potential characters that was put together by us and the working team in Hong Kong. For us, the basic criteria of creating a character was, you know, does it champion a distinct theme that represents Hong Kong? Does it have the potential to be playful and fun as a character, not just in terms of how it looks, but how it can potentially behave and sound? Is it a part of everyday Hong Kong life and easy to find as an object or a thing? And finally, Sean will go through it in more detail, but you know, it was really important that it had enough features to be recognized by ML. Is the object or symbol that triggers the character distinct enough so that, you know, machine learning is capable of recognizing it? So you'll see that ultimately you arrived, you know, at these characters that you see before you. We have the hiker twins who are all about hiking and nature and outdoorsy kind of activities. We have the electric neon sign, who's an advocate of SMB and retail. We have 2 F&B characters, fish balls and milk tea. We also have like this wonderful lion that's meant to represent, you know, Pride Rock, Pride Rock. Sorry, is it Pride Rock or Lion Rock? Sorry, in Hong Kong, which is just so iconic. And I think finally, last but not least, we have the Star Ferry, right, which is a part of everyday life in Hong Kong. And then naturally, the more you play and interact with these characters, you're capable of unlocking second skins as well. But for us, the real joy was having the opportunity to try and like figure out how these characters are going to behave. And each one has its own mannerisms. I'll play a few of them, but this isn't like a typical AR sticker where it just does the one thing. I think every character has about easily 10 different unique mannerisms, moves. So the more you kind of play with them, the more you discover something new about them. So again, I strongly encourage everyone to download the app and discover it for themselves. Beyond that, it was really important for us to kind of look at these characters through a very local lens, and we wanted to ensure that we came up with an interesting backstory and kind of give them a bit more color and context, right? So we worked with an amazing local agency in Hong Kong that helped to tell the stories of all these characters, gave them unique names, and really was something that kind of made them even more charming and memorable. So now I'm going to pass it over to Elaine, who's going to talk about the user experience in a bit more detail.
All right, thanks, Eddie. Well, hopefully by now everyone has downloaded it. So I'm going to do a very quick introduction, talk about the UX. So if we go to the next slide. So the left side of the video actually will showcase the app itself. I think app is the place where the native app is the place that we showcase all the features, all the user interactions, including a full onboarding sort of flow, tutorial flow, including the part that you can unlock all the characters, interact with them. It supports multiple characters and full sharing functions. Another thing we sort of play with is sort of join point system for people to collect join points to unlock badges and skins, and more importantly, connect with some local promotions, which I will talk a little bit in the partnership side. So the whole app, we're trying to make it fun and sort of gamify a little bit, but essentially this is the place that the user can experience all of the features how Jeng can offer. But besides the native app, what we also have is actually a web version, a lighter weighted version. So we actually started our thinking on the app itself, but essentially we realized that, like to make it more accessible for people, it's a good idea to have a sort of QR code activated light-weighted version for that. And for this, basically it is a web AI experience. As you can see in the right-hand side, through a specific QR code, you can activate a specific character, and then you can interact with the character a little bit. But more importantly, it becomes a nice hook that if you like the interaction, you can leverage the web experience to download the full app. So that's quite typical in the sense of like you use a sort of web experience almost as a trailer for people to download the full app. That said, though, another thing we realized is that when we talk to different partners, especially local commercial brands, NGOs, the web app experience becomes the best way for them to offer it to their consumers, their users, their target audience, to be easily put in different touch points to lead people to experience this. So I think in that sense, actually, web app really helped us to drive the scale of the experience itself. So just a very, very simple description of the UX for the app, for the native app, as well as the web app. Again, please download and try it out, and let us know if you have any questions around this. So moving on from this, I think I'm going to very quickly talk us through, all the partners we have in Hong Kong. The reason why I want to talk about this is that, it's one thing to build a tech product and launch it as Google, but it is another thing. It's actually quite a rich learning journey for our team to understand how to work with the local partners and launch it as a community effort. If you move to the next slide, you can see that actually we had so many different partners to help us. I know some of our Google Hong Kong team is also in the call today. We actually really learned a lot from them, and they are also the mastermind behind this very complicated map. So we are working with both, the commercial brands, whether it's the shopping malls, the hotels, like F&B brands, retail brands, but also working with different NGOs to really make it a community effort. I think I want to echo what Addie said earlier. The intention of this project is really sort of deliver the positivity to the community, through the community in a hyper-local way. So I think this is the way we are sort of making it happen together with the partners. So the next few slides will just quickly showcase some of the activations. What you can see here is our sort of activation partners with malls, and one of the activation I personally really like with GOD, goods of desire, with the mask. It just gives it a little bit of playfulness and a physical dimension of a tech product. Next slide. We also worked with local creative communities, which become a very interesting exercise. We realized that, okay, because of all the virtual experiences, but because of the characters, another thing Haojia can do is become an activity for the elderly communities as well as younger kids. So Isobar, the one of the top creative agencies, actually helped us to transform the characters and the fun experiences into activity books for those communities, and sort of help us to distribute that, add an additional dimension for the tech experience itself. Next slide. And of course, like when you think about a product activation, of course, we work with our creators. A fun AR app become a very natural sort of topic for them to engage, to create content and engage with their fan base. And the next slide, I think that's this is my favorite. I think I actually saw Nancy sort of pop up, just join the call. I think it's her brainchild. Our team actually built with some partners, actually create a Scratch sort of activity pack and 64 pages of a guide of how to use different characters to use Scratch to help to teach the kids to not just code, but also doing storytelling. So it's another good example to combining technology together with creativity to sort of promote STEM education. So those are, I think those can serve as some food for thoughts in the sense of how we can activate a product in different ways. And now I'm going to hand it over to Shan to talk about the technical behind it. I think we have some really good story to share here too.
Thanks, Elaine. Okay, let's talk about some technical details of the project. Next slide, please. So to start with the technical stack overview, as Addie and Elaine mentioned earlier, there are two main pieces to bring ShareJoy to life. The first one is to use AR Core / ARKit if you're using iOS to implement the AR part. And for this one, we decided to use Unity, the game engine, as our graphical engine, and also the one to deal with all the API from the AR SDKs. And the reason for doing that is Unity is really awesome in that you can just build the project once, and then you can just set the platform to either Android or iOS, and then you automatically get different builds for different platforms. So like this is really, really amazing for developers, because I still remember back in 2017, when ARKit first came out, and then when AR Core came out, we actually had to write Java or Objective-C in order to do anything in AR, because at the time there was no SDK. There was no one SDK which allow you to write stuff once and then build to AR platforms all at once. So like we were just like writing graphics code using OpenGL and then try to make it work with Java, and we're just like crying in a corner and like complaining, why is nobody doing this thing? So I think it's really awesome that we're in 2020 and Unity sort of just provide this for free. I'm sure Unreal Engine might have something in their pocket that's very equivalent to what Unity offers. And on to TensorFlow. So the main TensorFlow framework that we used here is the TensorFlow Object Detection API. It is a very well-packaged API in the sense that you don't need to know too much details of how actually the networks, like the different neural networks for object detection work. You can just have like a general knowledge of the pipeline required for training object detection models, and then you can just sort of follow the steps, prepare your data, follow the instructions, and at the end of the day, you get object detection models, which for mobile platforms are TF-Lite models that you can just use for your applications. So a bit of specifics. The TensorFlow we used for ShareJoy is TensorFlow 1. It has migrated to TensorFlow 2 since, but I think like TensorFlow 2 came out just this year, so it's a bit new. We would love to look into using TensorFlow 2 in the future, but TensorFlow 1 is way more enough to handle what we needed for this project. And the architecture we decided to use for TensorFlow is SSD MobileNet v2. And the reason for that is for all the architecture choices out there, there are several trade-offs you need to think about when picking which architecture is the best. For example, you might want to use a CNN model if you value accuracy more than performance, but SSD MobileNet is really good. SSD stands for single shot detection, and it's really good if you want to do anything real time, because it can give you pretty good detection for very performant FPS. And again, because we're using Unity, there's a plugin off the shelf that we could use to run TensorFlow Lite models. It's the TensorFlow Lite Unity plugin version 2.1. And with all of these packages, we were pretty ready to get AR and object detection working at the same time. So next slide, please. So how do we do the machine learning training? There's really not that much fancy coding going on when it comes to training your good object detection models. The key is to have as much data as possible, and it all falls on to collecting photos. So the sort of like the benchmark number we set it for ourselves when we set off to collect data for each of the categories. We wanted to get 1,000 images, and we wanted to get 1,000 photos initially, like all taken by human, essentially. But we soon realized that is not a very realistic goal given the current circumstances, mostly because, for example, we want to take photos of ferries, but we were caught in the middle of this whole COVID crisis. So we weren't even sure that if it's the best idea to encourage people to go outside and then go to the busy areas to take photos of the neon lights and the ferries, the hiker twins, like the hiker signs are probably okay because they're all outdoor. So in the end, we used a combination approach of using about 90% of web search images and then 10% of photos. And the photos are collected mostly with the help of Hong Kong Googlers, who we're very, very grateful for. And then we even built a custom data collection app so that we can make it easy for people to take photos and then label what objects are being seen in the photo. A bit of a side note here is it's great that we have this awesome tool for people to collect photos. It was actually really well designed. We had the whole flow going on. You can just open up the app, and then it has a camera function in it, so that you can take a photo, and then right there you can like draw a bounding box and say, okay, I'm seeing a fishbowl or I'm seeing a milk tea. So it was a great flow, but we realized the main goal of this whole thing is actually to get people to send data to us. And sometimes when that involves getting people to download a new app, they'll see that, oh, okay, I have to follow these instructions to get the app in the first place. And that sort of added some friction when it comes to offering their help. So we ended up also providing an alternative approach for people to just send us their photos, because a lot of people actually have a lot of photos of many of these categories already in their photo gallery. For example, like I'm sure if you just scroll through your camera roll, you can find a few photos of, say, fishball or milk tea that you have just taken throughout the years, right? So also one of those photos that people have already taken. That's why we wanted to open it up for just uploading things to Google Photo or Drive. We just want data, so whatever is the most accessible way, we ended up going with it as well. And we even experimented with using Mechanical Turk for collecting photos. For those of you who are not familiar with Mechanical Turk, it's basically a crowdsourced task platform, so that you can create a task on Mechanical Turk, which is part of Amazon these days. And then you can say, hey, I'm going to offer this amount of money if you can help me collect, say, 100 of photos of fairy. So it's kind of like a freelance, crowdsourced task platform. But the lesson we learned is that there are actually not that many Mechanical Turk users in Hong Kong, because this is a very, very region-specific thing, is what we realized. Because we want to, all of the objects that we're collecting photos for are unique to Hong Kong. So there's a lot of cultural related stuff you can only find in a specific area, right? So when we create this task, we only create it in the Hong Kong area, so that if you don't live here, we appreciate the help, but we don't want photo from you. And then we realized because I guess I don't know what exactly it is. Maybe the price we're putting out there is just not that appealing. People just have a general higher expectation. I don't know. We don't need to go there, but there are not that many users providing data from Mechanical Turk. So that's a lesson learned with that regard. We even tried a few other platforms, such as, sorry, I forgot the name for it. Fiverr. Fiverr was one. There was another one. I forgot the name of it. But not a lot of luck for either of those platforms. Okay, if we could go to the next slide, please. So this is just to give you an idea of what kind of photo we were collecting, and once we have the photo, what kind of information we're labeling. So the easiest way to think about it is we're just labeling bounding boxes with a class label there. So there are obviously 6 classes: milk tea, fishball, line. Oh, actually, there are a few more than 6, because some of the categories have more than 1 classes. For example, milk tea. For milk tea, we have milk tea ceramic. This is for when milk tea is served from a ceramic cup, or milk tea plastic, or milk tea glass cup. So we ended up having this many classes, and we used, so you can see on the right-hand side that this is the final number that we ended up using, number of photos for each category. So we had a lot of fish balls. So apparently it's not that hard to find photos of fish balls. But for example, we only had 200 something for the lion statue. So it's a little harder to get images for that. We also only had 300 photos for line dance, which is the very cultural, the red dancing rock kind of image. We'll go to the next slide, please. So some of you might be wondering, when you are looking for more data, what are some of the ways that can help you get more data without actually having more photos? Because sometimes it's just impossible to get more photos, right? So we had to get a little creative here. One approach we used, which I call data augmentation, is to create new photos from existing photos. So, for example, we wanted to train an object that could object detector that could recognize distance post signs that you can see again and again in all these hiking trails, right? We will only have this. What can we do if we only have this label of the hiking post? Like the easiest thing you can do is just to print it out and then try to mimic the environment in which you can usually see this distance post. So the team that we're working with to help build this machine learning model is based in Thailand. This is what you can see that they're trying to print this out and place it in like very tropical, like very green background to mimic some of the actual setup. And I think this worked out pretty great because when you think about what machine learning model is picking up when it is training this object detector, is probably not the post or like the stand that supports the post. It's actually probably going to be focusing on the features that actually represent the hiker icon. Right? So by augmenting data this way, we're keeping those features, but we're compromising on some of the other aspects of the photo that might not matter that much to what we want to detect. Of course, this is just a hypothesis. It's very difficult to evaluate how well or how badly this actually worked, but we would like to spend more time to see what is the performance between the simulated data and the actual data. If we go to the next slide, please. So another fun story for how we were trying to get more data is we tried to simulate photos for the ferry because, as mentioned earlier, we were having trouble getting photos for the ferry. And we came up with the idea, if we go to the next slide, please, to find a model of this very iconic looking ferry and then placing it in a simulated environment in Unreal Engine 4. And I think the reason why we went for Unreal versus Unity here is Unreal is known to do a better job at rendering realistic photos than Unity, which Unity folks will probably not agree with me. But as you can see from the GIF here, Unreal is actually doing a really, really good job recreating some of the scenes that you might see. Of course, I'm not saying that you can actually see something like this in real life, right? Like this looks like a lake, and you have some of the background, you have some of the plants. But I think like all we needed was to get a realistic looking rendering of the thing. And then once we have it, we can start playing with the different positioning of the subject. We can create a mid-range shot. We can create a close-up shot. Since this is in the virtual environment, we can really move the camera however we like. We also have the ability to control the lighting of the environment. So it's quite easy for us to simulate, for example, like a photo of a ferry in the daylight versus sunset, or even like versus at night. Although I don't think we simulated anything else because it's just hard to see stuff at night. Okay, if we go to the next slide, please. Yeah, so as you can see here, this is just a range of shots that we simulated for the ferry. Again, these are just some of the approach you can go to when you really have trouble getting more photos, but nothing will compare to real life photos. And for the real life photos, nothing will work as well as those that actually mimic your real use case. which in this case means actual photos taken from your mobile phones, because this is what the real setup will be when the user actually use the app, right? You could have like very nice looking photos taken from DSLR, but this will not be the same kind of images that people observed when they use their mobile phone. So like the best kind of data is the real kind of data. So that's, I guess, is just a side note there in case you're looking for data to train your own model. All right, next up, let's talk about some other trouble that we had during the building of the app. So we quickly realized that once we have everything together, so the app is running beautifully, the whole user flow is there, TensorFlow is working great, and AR is working great, but there's a problem, which is the phone heat up really quickly. Well, not really quickly, but like very visibly, or very sensibly heats up after you start using it for a while. So we start digging into this issue and see what's the root cause for it. So we use the profiler in Unity to see what is the actual CPU usage and GPU usage for the AR SDK and the object detector. And as you can see here, well, I guess it's I'm not sure if you can actually see it, but in the profiler here, we have a thing called AR Camera Manager, which is the manager class responsible for running AR. And then we have a Core Manager, which is the manager for running ML. And the CPU percentage here is 44% something versus 34% something. So they're really taking up much of the CPU power here, and the usage here between the two components are roughly comparable, with machine learning being a little bit heavier. If we go to the next slide, please. And we're also wondering, like, what does it mean for the GPU side and like some of the rendering stuff? So we decided to do a incremental use an incremental approach to debug this issue. So we started by turning everything off and only leave the animation running. This means that there will only be rendering and like all the 3D object rendering graphic stuff going on. So we left the app running for a while, and as you can see here, starting from minute 0, it's at 45 degree, and then after 5 minutes it goes up a little bit. After 10 minutes it goes up a little bit more, and 15-30 minutes it all goes up in a relatively okay fashion. So there's not a huge jump between all these numbers. So we're like, okay, this is we can live with this. And now let's go to the next step. Next slide, please. So we tried turning AR on and see what's the impact of AR once we bring it in. And if we go to the next slide, please, we actually start seeing a big jump in terms of the heat generation after 10-minute mark. So as you can see there, 10 minutes is still fine, and compared to the animation only profiling, it's actually not that much different. But when you go from 10 minutes to 15 minutes, the temperature increases by almost 10 degrees. So this is pretty bad. So we're getting a little suspicious about AR Core. So if we go to the next slide, please. Okay, now what happens if we bring ML in as well? And next slide, please. So as you can see, the temperature for 10 minutes actually is higher than that without the ML, but it's okay-ish. Actually, it's not okay. It's already pretty high. And at 15 minutes, it's 66 degrees, which means it's already quite hot, feeling quite uncomfortable. So that confirmed our suspicion that with AR core and ML, we're starting to see a heat issue at around the 10-minute mark. And if we go to the next slide, please. And as a benchmark test, right, we wanted to see what the temperature looks like when we run the camera app that comes out of the box with Pixel 4. So a bit of context, the camera app is actually a AR app provided by Google. So when you go into it, it runs the whole AR core framework, and then you can place stickers, 3D stickers kind of in AR, and then play with it. So like some of the user flow is quite similar to what ShareJoy does. And if we just run that app and we look at the temperature, I think we're looking at 5 minutes, 10 minutes, and 15 minutes here. So oh, sorry, I think it's 0 minutes, 5 minutes, and 10 minutes. So at 5 minutes, it's already at 60 degrees. So this is completely standalone from ShareJoy, right? So this is just running AR core plus the 3D rendering stuff. So this is pretty unfortunate to see, but at the same time, we're like, okay, I guess this is something that is generally applicable to all of your AR apps out there running 3D rendering. So if that's what camera apps get, I don't think there's anything specific we're doing in in ShareJoy that is causing the issue. So if we go to the next slide, please. I guess a lessons learned here is using AR Core and ARKit is very likely to create a heat issue no matter what. And this is just something general for AR apps. And if you're designing an AR app yourself, and if you're looking to do some heavy computation there, it's probably a good idea to brace yourself for some of this issue that might happen. And I guess some of the workarounds we can do here is you can plot out your execution flow so that your computationally heavy components don't have to run at the same time always. For example, if you're running AR, maybe it's not required to also run ML as well. So this is actually the case for ShareJoy in a lot of the case. For example, a lot of the people, when they're scanning their first characters, there's nothing in the 3D scene yet. So we only need to run machine learning model itself. We don't need to run any of the AR component. So AR being the main energy drain, so if you delay running it, you can save a lot of the energy consumption when you don't need to. There's another catch for this kind of user experience, which is when you are designing for a scanning step, scanning is actually a very common use case these days, right? You don't actually have to run your object detection model at very high of a FPS because nobody cares. Even if your object detector runs at like super beautifully like 30 FPS, it's very difficult to notice the latency between an object actually being recognized and all of the subsequent stuff. So even if you only run your object detector at 3 FPS, which is pretty low for real time, it's already fast enough because it's a scanning use case. Like people just want their object to be recognized. They don't care how fast it is recognized as long as it's reasonable, right? So yeah, I guess these are just some of some of the best practice we would like to recommend. And with that, I think that's all of the tech sharing from me. So over to you, Eddie.
Yeah, so I mean, I think now, again, thank you so much, Shan, for sharing those invaluable insights. I think, just listening to you tell the story of what we went through to build this, even I, as part of a team member, I'm just like amazed / kind of in awe of, the kind of challenges that we had to kind of overcome. So we're actually still very good for timing. We have about 10 minutes left. At this stage, if you still haven't downloaded the Jeng app, especially now that you know how much kind of effort and energy came into ensuring that we could kind of create it and help it work and help it to be as great as it can be, please take the time to download the app and kind of experience it for yourselves. Not just for fun, but just for as a learning, just to kind of see what you can potentially kind of gain from it. So the next 10 minutes is really up to you. If you have any questions, you don't necessarily have to speak up. You can just type it in the chat, and Sean, Elaine, or I, or anyone else from the Google Hong Kong team will try and give you as much context or clarity as possible. Are there any questions? Okay, so all right, I think I will take the silence as as wholehearted comprehension. If anything, like I said, please instead download the app, discover what we've created for yourselves, and when you get the chance, please share with your friends across your socials. Okay, I think I did just see a question here. Freddie asked, will you add more characters in the future? That is absolutely our ambition, Freddie. I think with our team, it's one thing to just kind of, build something or make something. Naturally, we want it to have like longevity, and ideally, especially next year, there's a lot of like, amazing kind of milestone occasions and festive periods around the corner that could allow for new characters and new ways of using the app.
That would be great, because I've got all 7 of those on my phone. So
you got also okay. Well, try to get the second skins if you haven't yet. But yes, watch this space. Hopefully, we'll give you more reasons to play with these characters in the near future.
Thanks.
Okay, we've got another, not quite a question, but from Oryx. Hi, not really a question, but just want to say I'm very impressed with the creative techniques you guys took in doing data augmentation. Big smile. Thank you so much. Sean, would you like to comment on that? I think that one goes out to you specifically and the crew. Yeah.
Thank you, thank you. I hope this is really some of the last resort that we're sharing here. But it might happen more often than you think. So it's always good to have those approaches in your toolbox.
Absolutely. We've got Hay says, thanks, Elaine, Sean, and Eddie, for sharing. Thank you for listening. Thank you all for taking your precious time in the evening to hear what we have to say. Desmond just asked, is it possible to use Google image search to get the training image? Any copyright issues? Sean, Elaine?
Yes, definitely. We actually used a lot of the images from Google web search. Copyright issue, maybe, depending on which ones you choose. But I guess this really falls into some of the gray area there. Like if you choose your data wisely so that it provides a good representation, hopefully it doesn't perform in a way that can single out a particular type of object that might cause some of the copyright issues. So I guess that's one way to work around it. Yeah.
Yeah, absolutely. I think the general conversations we were having as a team was like, we just need more photos. And every time everyone asked us, what can we do to make it better? We just said, we just need more images. So I think it came to a point where, as Sean had shown, we had to kind of create our own ferries and create our own images around that, whatever it took. So I'm just reading through the rest of the comments here. Andrew said, I've just unlocked all characters. Well done, Andrew. You deserve joy points for that, which I'm sure should be in the app. Thanks for the sharing. Thank you. Chui just said, what are your initial thoughts? Sorry, what was your initial thought when you were thinking of developing in not just iOS, Android device, but in web as well?
Oh yeah, I guess this is one thing that I forgot to mention. So HereJoy also has a web component to it. So we were actually really amazed by the ability to do AR on both iOS and Android. So like at first we thought it was only possible to do it on Android web because like Chrome is streaming essentially all of the camera feed to AR Core, and AR Core is doing all the computation. That's how we do it. And then we found out that ARKit can actually do the same thing. So it was really not that hard to get AR to work in web these days. You just basically call some API. I think I forgot the name of the APIs, but it's very easy to find. You just do some Google search and then use those packages. So it's overall very enjoyable experience and something that I would absolutely encourage you to try if you're interested.
Yeah, and just to add to that, I think, we wanted to cover our bases. So no doubt, while the native app kind of allowed for a lot more kind of functionality and features and the quality of like the characters were, was far more kind of detailed. I think the web app was the one that kind of helped spread the word and gave a lot of downloads for us. But I think it's always good when they're all kind of mutually connected. Ultimately, the web app would still kind of encourage people to download the native app because you could only access one character every time you score. If you were to scan a particular QR code, it would open the web app, but it would only give you access to just one character. So naturally, there were like these silhouettes of the other characters. If you were to tap on them, it would invite you to just download the native app instead. So yeah, none of them are mutually exclusive.
Yeah, absolutely. And I guess like one last thing to add for the web is it's actually easier than building on for mobile because you're using the SDK. You don't even need to worry about rendering or the graphics stuff yourself. All you need to do is provide the SDK your models and animations, and we'll just play it for you. So that is it's just a lot more lightweight compared to the mobile approach. Of course, with that comes more constraints. For example, like you can't do as many types of interactions as you can do on mobile because web AR is kind of like a sandbox. You can only view it, you can place it, you can like scale it up and down, but that's pretty much what you can do in terms of interaction.
Okay, I think those are all the questions and comments. So once again, okay, one more. Is Flutter involved with the app development?
Sadly, no. Actually, have a lot of engineer friends who are really enjoying Flutter now, but I haven't heard anything about Flutter and AR. So I guess if there's a AR plugin for Flutter, then that's like the green light for doing AR related stuff. But I'm not I need to check this part. I don't know. Sorry.
Okay, so yes, I think now we are done with the questions. Again, thank you so much for your time and joining this week's session. We've had just as much fun sharing the story as we've had just kind of talking, reacting to all these questions and like really lovely comments from everyone in this group. So like we said, it's TensorFlow's 5th birthday. Let's celebrate it with a big bang and just start kind of experimenting and doing all kinds of stuff. So thank you all for your time and have a great night. Goodbye.
Thank you, everyone.
Thank you.
Bye.
Yeah.